Hello, my name is Michael Kaler, and I am the lab manager of the IM Diffraction facility located at the University of Tennessee, Knoxville. If you would like for us to test some samples for you, please just send me an email at this address and we can discuss the cost. As you can see, right now I have the reflection transmission spinner stage installed, the programmable divergence slit, and my pixel detector. A lot of this will need to change. I'm first going to change my sample stage to the flat sample holder. Let me close the doors. I have just finished breeding the tube. Before I move over to actually switching out the sample stage, let me point out that you need to check your detector humidity and temperature. Humidity should be 0 and temperature should be -30. If any of these values are not correct, then you should check your water chiller and your dry air unit to make sure that they are functioning properly. If you don't have this down here, these two fields, you can come up here to User Settings, Status Bar, and you can choose your different options for 1 through 5. I see here that I have detector humidity and detector temperature. Let's now go through and switch the sample stage. To do that, we will choose Instrument, Disconnect. I'll choose OK. We will now go to Tools and then Exchange Sample Stage. I see here that my active sample stage is the reflection transmission spinner. I want to install the stage for flat samples/holders, so I'll choose that and click Apply. This says that the wizard will walk us through the necessary steps. I'll click Next. This says to remove all incident and diffracted beam prefix modules and accessories from the system. Now, I know that with the programmable divergence slits and pass on the pixel with this sample stage, I don't really need to do this. Nothing is going to collide if I leave them on there, so I will click Next, but I will not be held liable if any collisions occur that cause damage to your system. If you want to do this the most proper way, I would recommend removing the incident and diffracted beam prefix modules. I'll click Next. It says to remove the sample stage reflection transmission spinner, so I will do that. I will loosen the screw on the right hand side and then loosen it more. This will drop down a little bit. I'll just slide it on out. I'll click Next. It now says to install my other stage. This is the stage that we want for aligning the silver X-ray tube, so I will install that. Tighten up that screw. Make sure it is tight enough with this. Close up my doors. And next. Click Finish. Now I will go back to Instrument, Connect, and I will choose my Flat Samples Holder option. OK. No red X's, so I'll click OK. I'm going to start out leaving on the programmable divergence slits, but I'm going to change out the diffracted beam side so that I have my Galapix detector. I'll grab this here, loosen the screw back here, and then slide this in the wooden block on the bottom of the chamber. I'll grab my Galapix. Here you see it. It has this nice little handle on the back for lifting it. I'll slide it right in the same place that the pixel was. Tighten up this screw. and then make sure it is tight enough with our 3 Newton meter torque driver. There is a little more that I need to change on this end for alignment. Right now, we have our 10.3 millimeter anti-scatter device installed. What we want to install is our 7 millimeter anti-scatter device. I'm first going to remove this, but in order to do that, I need to loosen this thumb screw that you probably can't see. It is right behind the anti-scatter device. I'll loosen that a little bit, and that will let me slide off the shielding. Here you can see that our solar slit is installed. You always want to make sure that it is installed. With the shielding installed, it is easy to not notice if the solar slit is missing. I'll next remove this thumb screw. There we go. I also removed the little piece here that helps hold the shielding in place. I can grab this, and to remove it, we will loosen the screw back here. Here is our 7 millimeter anti-scatter device. You can see that this part here is longer. I'm going to attach that, once again with this screw back here. I'll put this piece back on. I won't tighten it all the way quite yet because I need to put on the shielding. I'll slide that on, and then tighten up that screw. And there we go. Our diffracted beam side is now all set up. Like I said, for the incident beam side, I'm going to leave the programmable divergence slits installed, but we do need to change some of these optics. First off, I'm going to insert a copper 0.4 attenuator. You should be able to see it right there. This will help absorb some of those X-rays so that we don't risk damaging the detector. That's going to go just to the left of the solar slit and should slide in very loosely. I see that I have the 0.02 radian solar slits in there. Technically, you don't even need solar slits for this part of the alignment, but I'm going to swap them out anyways so they match the other side. That means that I will use the 0.04 radian slits. For our mask, I have a 10 millimeter mask in there. Just like with the solar slits, you can use it, don't use it, it doesn't really matter, but I'm going to leave that in there. For the divergent slit, we want that to be 1/32, so that means we want our anti-scatter slit to be 1/16. I'll install that. We should now be ready for our first scans of alignment. In my instrument settings, I'm going to come in here and set this to be 0 and 0. X-ray should be 30 and 55. I'll click OK. Let's announce the changes we made to our hardware. Incident beam optics, I'll double click. I still have this prefix module. I want to use the 1/32 divergent slit, the 1/16 anti-scatter slit, 10 millimeter fixed incident beam mask, no beam knife, 0.04 radian solar slits, no filter, the copper 0.4 attenuator. This attenuation factor isn't correct, but it doesn't really matter. I'll just choose Do Not Switch and Activated. And then I have no mirror. Click OK. And OK. And OK. Come over here to Diffracted Beam Optics, double click. My prefix module is no longer this. It should be my Galapix 3D FAS for capillary transmission. This may be different for you. I see my anti-scatter device is automatically set to the one I have on there. That's just the way that my configuration file is set up for this prefix module. I have no receiving slit, no filter, no beam attenuator. My detector, this is already set to the correct settings. Yours might look like it has some other active length here. If that is the case, just type in 0.04, hit tab on the keyboard, and we are looking for 3 active channels there. This is now good, and we want scanning line detector 1D. No collimator. We have our 0.04 solar slits, and no mask. I'll click OK, and OK. I recommend checking your upper and lower PhD levels, which you can see here. For PDF measurements using this hardware, you want the lower level to be 25% and the upper level to be 70%. If yours are set differently, you can go back to your Detector tab, click Set PhD Levels, and then set them as shown here. I'll come back here because I like to watch this information. I will click Measure a Manual Scan. We will start out with a 2 theta scan, and these settings look fine. We see that our direct beam 2 theta scan shows that our maximum intensity is below 0 degrees. It is at about negative 0.07 degrees. What we want to do is adjust the tube height so that this is within ideally 0.005 degrees of 0. I believe to be in spec it needs to be about plus or minus 0.01, but I prefer to try for 0.005. Let's go into the sample chamber and adjust this tube height. How you go about adjusting your tube height depends upon what kind of tube housing you have. I advise you to make small changes until you get a better feel for how to align a tube. You may not want to try doing this unless you have been trained by Panalytical in the past, because you can really mess up your tube height alignment, so be very careful with this step. We currently have the newer housing, so I will show that to you in a moment. If you have the older housing, back here, you will feel or see 2, I believe, black knobs. One is higher, one is lower. In order to adjust the tube height, you slightly loosen one knob and tighten the other. In our case, because the peak is too low, I would loosen the bottom knob and then tighten the top knob. I would do about 1/4 of a turn at most, which means you would loosen the bottom knob 1/4 of a turn, tighten the top knob 1/4 of a turn, and then perform another direct beam 2 theta scan to see how much that peak moved. You would then continue adjusting from there. As I said before, we have the newer version of the tube housing, so let's see how we are going to adjust that. Instead of adjusting 2 knobs back here with the old housing, we have this screw here that we turn to adjust the tube height. Before we adjust that though, there is this handle with a knob back here that we need to loosen because it locks the tube height in place. To do that, I will push this towards the back and bottom of the chamber. That's now loose. You can see a counterclockwise arrow with an up arrow and a clockwise arrow with a down arrow. These tell me which way I need to turn the screw in order to make my peak go higher or lower in 2 theta. Now this applies to the programmable divergent slit prefix module. From my experience, it is the opposite for mirrors. Because I need to move my peak to higher values of 2 theta, I need to move it up, which tells me that I need to turn this screw counterclockwise. I will turn it, I don't know, maybe 1/16 to 1/8 of a turn. Once you are done turning the screw, you want to make sure that you lock your tube back in place. Let's go perform another alignment scan. Click Start. I went a little too far. I'll right-click, peak mode, and I see that I'm at about 0.0085. Let me go back to the chamber and turn that screw clockwise by a very small amount. I'll loosen the tube, turn the screw the other way, which is clockwise, by just a little bit, almost nothing. I'll lock my tube back in place, close the doors, and take another scan. Right-click, peak mode, 0.0035. Beautiful. That's going to be our starting position. What I like to do is save these scans so that I can keep track of how I've been aligning the system. If I later wonder if I made a mistake at some point in the past, I can look at these scans. I will save this by going to File, Save As, click the folder icon. I see that I keep track of all the dates in which I have made this tube switch. I will make a new folder and give it today's date. Actually, what I'll do is navigate to my previous folder and copy some of these files. I'll organize by date modified. I'll take these, copy them, and put them in my new folder. This will help me save some time on naming each file. I'll come in here. My step 1 is using the PDX in Galapix. It is a direct beam 2 theta scan after I adjusted it. All I need to change is my date, and then I'll save that. I'll do this for each one of these steps and then try to remember to delete out the old ones once I'm done. As you saw, I don't always remember to delete the old ones, but it is easy enough to keep track of what's what. I'll save that and say OK. We are ready to move on to using the focusing mirror. Before we do, I have a little bit of a note on what you may need to do with the hardware to prepare. This is the focusing mirror, which is what we need to load on the system. I can tell it is focusing because it has the beam diverging, hitting the mirror, and then refocusing. I can tell that it is for the silver mirror because it says so right here. I see that we have this hardware attachment, but we don't really want any attachment on here for alignment. If you have performed PDF measurements in the past, you might have this attachment on there. It would sit there just like that. This would be removed. This would be attached back here. Regardless of which hardware attachment you have installed, the way to remove it is the same. There is a screw here and here. All you do is loosen those. I'll hold it from here and pull from the main body. Sometimes it can stick a little bit. I took out the other screw. I typically put those in a little bag so I don't lose them. This is how we want to load the mirror on the system. Nothing needs to change on the diffracted beam side, but we will take the programmable divergence slit off. I'll hold it like that, loosen that screw back there, and then put this in the wooden block in the bottom of the chamber. I'll load this on there. We need to install two things in the mirror for now. The first thing is a divergence slit. which is what we have here. Hopefully you can see that it says 1/16 tantalum. Ideally, we would use a 1/32, but I'm not sure where mine is, so this will do. You see that there is this little notch here, a decrease. If you want to know the correct orientation of this in the mirror, imagine that you are putting your thumb in that and install it. Essentially, the text should point left. You want to be careful when sliding that in there. If it goes in too far, you'll have to take this whole thing off to get it back out. Insert it until it clicks. We next want to install our attenuator so that we are absorbing some X-rays. I hope you can see that we use the copper 0.4 and rhodium 0.06 attenuator. That should go in with the numbers facing right. So push that all the way in and pull it back until it clicks. That's it for the incident beam side. We do need to make some software changes to the incident beam optics. We need to announce that we changed the prefix module to the focusing mirror with silver. The divergence slit is 1/16. No anti-scatter slit, no mask. No beam knife, no solar slits, no filter. Our beam attenuator is the copper 0.4, rhodium 0.06. This attenuation factor is correct, and I will once again set it to do not switch and activated. The mirror is automatically selected. I can't click on it because we already said in the prefix module that we have a focusing mirror. I'll click OK. I already did all this, so I'll click OK. OK. I don't need to do anything else to my diffracted beam optics because I didn't change anything. So I'll come back over here to my instrument settings and perform another 2 theta scan. The peak should still be quite close to 0, but let's see. We see a much weaker peak, and it is located at negative 0.0072. In theory, we could go through and realign the tube height like we did for the programmable divergence slit, but Panalytical has found a more accurate way of doing this, which involves testing a single crystal. What I have is a single crystal wafer of gallium arsenide that I will install. This is my nice single crystal of gallium arsenide, and I will install it in this clip. I will lower the clip, slide that wafer in there, release the clip, and that's it. We also need to remove the attenuator. I will first announce that I removed my attenuator, set that back to none, and OK. OK. I'm also going to come over here and use a little more of the detector. I'll double click and want to use about 200 active channels, which I believe is about 3 degrees. Yep, 209 channels, that's fine. I'll click OK. I'll come over here to instrument settings, double click. I need to position my 2 theta and omega at angles where I know I will see a diffraction peak from my single crystal. For this gallium arsenide, I know that is around 22.87 degrees 2 theta. I want that to be 0. That's good. For X-ray, I want to change these to 60 and 36. I'll click OK. we are going to perform a 2 theta omega scan. I like to use 1.5 degrees, 0.007 step size, and about 15 seconds. Start. We now see our K alpha 1 and K alpha 2. The goal is going to be to adjust the tube height so that our K alpha 2 to 1 ratio is 0.5. If the tube height is off, that ratio is also going to be off. Let's first go to File, Save As. Click the folder icon. This is now my, well, normally I save that other scan with the focusing mirror and the Galapix before I make any adjustments. I forgot this time, but it doesn't really matter. This time, I'll just move on to my Focus plus Galapix on the gallium arsenide substrate. No adjustment, so this is my first scan of it. Change that date, enter, and OK. Let's go over to HiScore Plus, File, Open, go down to 822, Organize by date modified. That way my newest one will be on top. I'll open that. I'm going to right click, determine background, give it something that looks pretty good. That's not bad. I'll right click, insert peak, left click, right click, insert peak. I'm going to turn off the individual peak profiles so that I can see the blue calculated profile better. Come in here to Refinement Control, Global Variables. I think I'll bump up the solver tolerance a little bit by adding another 0. I like this background, so I'm going to use available background instead of having it refine the background. I think that's it. I will click this and perform a default profile fit. Not too bad. I click the plus sign and then click this little button here to refine the K alpha 2 to 1 ratio. I'll now change this to manual and click the fitting button. I see that it is about 0.56. While 0.5 would be perfect, we want some value here between 0.4 and 0.6. Be warned though, the farther away from 0.5 you get, the more performance you are sacrificing. Ultimately, it comes down to how much effort you want to put in to get closer to 0.5. 0.56 is a little bit more than I like, so I'm going to adjust the tube height to hopefully improve it. Let's come over here, loosen up my tube. If my ratio is above 0.5, that tells me that I need to rotate this counterclockwise just a very tiny bit. I did almost nothing. Not even a 1/16th of a turn. Let's perform another scan and see if our ratio is any better. Let's go to File, Save As. I have my old adjustment 1 here. I'll make that 22, enter, and OK. What I can do is come over here to HiScore. I already have a lot of this stuff set up as I want it, so I'm going to go into my scan list, left click that, hit delete, and then insert my new data file, my adjustment 1. Right click, determine background, and keep the same bending factor and granularity for consistency. I'll choose accept. Go to my refinement control, set this to 0.5 to get a nice fresh start. Do my default peak profile fits. Click that. It was 0.56, now it is about 0.537. That tells me that I got closer. I think I'm going to try to get this a little better though. I'm going to keep adjusting that tube height and performing new scans and refinements until I'm happy with this ratio. Oh, look at that. Almost exactly 0.5. That is excellent. That tells me that this refinement is good. Personally, I would say that this is probably good enough in terms of alignment scans. During training though, we did one more direct beam 2 theta scan without the sample present. For completeness, let's go ahead and do that. Before I forget, I'm going to put my attenuator back in since we will be performing a direct beam scan. I'll hold my crystal, pull down on the clip, and remove it. That's it for hardware. Let's announce the changes. We have our incident beam optics, double click. All I did was put the attenuator back in, so I will change that. Do not switch and activated. OK. OK. For diffracted beam optics, I want to set my detector back to 0.04 and tab to get my 3 active channels. OK. I'll come back here to instrument settings, double click, change all this back to 0. For X-ray, I'll set that back to 30 and 55. Say OK. I'll do my 2 theta scan, maybe 1 degree. This should be about 0.5. That ends up with a scan time of about 26 seconds, which seems good. I'll start that. While that's running, I'll come over here to high score and save this as an HPF in case I want to go check it again in the future. We see that the direct beam still isn't all that nice looking. If we right click, peak mode, we are still sitting a decent ways off, 0.01. Panalytical has said that it is better to have your K-alpha 1 and 2 ratio be correct than to have this be perfectly aligned. I will file, save as, folder icon. Step 4 is the Focus plus Galapix direct beam again. I'll make that 22. OK. Before I forget, I'll come in here and get rid of everything that wasn't collected today. That's pretty much it for aligning the silver tube for PDF measurements. If you have any questions, please leave them in the comment section below. Otherwise, Benjamin and I thank you for watching, and we hope you have a great day.